Hi guys, welcome to my study compass. In this video, I'll be walking you through the past paper, Math P4, variant 2, February March 2022. Let's get started. A company employed 300 workers when it started and now employs 852 workers. Calculate the percentage increase in the number of workers. The percentage increase is equal to the increase in the number of workers, which is 852 minus 300, divided by the initial number of workers, which is 300 times 100%. This gives us 184%. Of the 852 workers, the ratio part-time workers is to full-time workers equals 5:7. Calculate the number of full-time workers. The number of full-time workers is equal to the ratio share for full-time workers, which is 7, divided by the total ratio of 5 plus 7, which is 12, times 852. This gives us 497. The company makes 40,600 headphones in 1 year. Write this number in words. Here is the number written in words, 40,600. Write this number in standard form. To write this number in standard form, we move the decimal point from the end of the number to a position after the first non-zero digit, which is 4. This gives us 4.06. Since we moved the decimal point 4 units to the left, we multiply 4.06 by 10 raised to the power 4. In 1 month, the company sells 3,000 headphones. Of these, 48% are exported, 3/8 are sold to shops, and the rest are sold online. Calculate the number of headphones that are sold online. First, let's find the number of headphones that are exported. To get this number, we multiply 48 over 100 by 3,000. This gives us 1,440. To get the number of headphones sold to shops, we have 3/8 of 3,000, which is equal to 1,125. So now the number of headphones sold online is equal to 3,000 minus the sum of 1,440 and 1,125. This gives us 435. 1 year, sales increased by 15%. The following year, sales increased by 18%. Calculate the overall percentage increase in sales. Let's represent the initial amount of sales with Y. If in 1 year the sales increased by 15%, then the new sales value would be 115% of Y, which is equal to 1.15 Y. If in the following year the sales increased by 18%, then the new sales value would be 118% of 1.15 Y, which is equal to 1.357 Y. So now the overall percentage increase is equal to the increase in sales, which is 1.357 Y minus Y, divided by the initial sales value, which is Y, times 100%. 1.357 Y minus Y is 0.357 Y. The Y cancels out, so 0.357 times 100% is 35.7%. The table shows some values for y equals x squared minus 1 over 3x, where x cannot be equal to 0. The y values are rounded to 1 decimal place. Complete the table. When we plug in x equals negative 0.75 into the equation, we have y equals 1.0 rounded to one decimal place. For x equals negative 0.5, we have y equals 0.9 rounded to one decimal place. On the grid, draw the graph of y equals x squared minus 1 over 3x for x is greater than and equal to negative 2 and less than and equal to negative 0.1. The graph of y equals x squared minus 1 over 3x for x is greater than 0 has been drawn for you. So on the grid, we plot all the points given in the table and connect the points with a smooth line. By drawing a suitable line on the grid, solve the equation x squared minus 1 over 3x plus 1 equals 0. First, let's rewrite the equation to leave the function of the curve on one side of the equation. This means the line we need to draw on the grid is y equals negative 1. And we need to find the x-coordinate of its intersection point with the curve. On the grid, we've drawn the line y equals negative 1, and the x-coordinate of the intersection point is 0.3. Find g of f of 3. First, let's find f of 3. To get f of 3, we replace x in f of x with 3. So we have 1 plus 4 times 3, which is equal to 13. So now, to get g of f of 3, we replace x in g of x with f of 3, which we found to be 13. This gives us 13 squared, which is equal to 169. Find f of g of x. To get f of g of x, we replace x in f of x with g of x. This gives us 1 plus 4x squared. Find f inverse of f of x. Whenever we are finding the inverse function of the same function as in this case, the result will be whatever is in the bracket, and for this case, this is x. Find the value of x when f of x equals 15. We've been given f of x as 1 plus 4x. So we have 1 plus 4x equals 15. When we subtract 1 from both sides, we have 4x equals 14. And when we divide both sides by 4, we have x equals 3.5. In triangle ABC, AB equals 45 centimeters, AC equals 29.5 centimeters, BC equals 35.3 centimeters, and angle CAB equals 51.6 degrees. Calculate angle ABC. To get angle ABC, we apply the sine rule. This gives us sine of angle ABC divided by 29.5 centimeters equals sine 51.6 degrees divided by 35.3 centimeters. When we make angle ABC the subject, this is what we get. When we type this into the calculator, we get 40.9 degrees rounded to one decimal place. Calculate the area of triangle ABC. To get the area of the triangle, we apply this formula. If we pick these two sides of the triangle, then we need to pick the angle between the two lines. So we have half of 29.5 centimeters times 45 centimeters times sine 51.6 degrees. When we type this into the calculator, we get 520 centimeters squared rounded to 3 significant figures. The diagram shows a quadrilateral PQRS formed from two triangles, PQS and QRS. Triangle PQS is isosceles with PQ equals PS equals 32 centimeters and angle SPQ equals 56 degrees. QR equals 47 centimeters and angle SQR equals 60 degrees. Calculate SR. To get SR, we apply the cosine rule to triangle QRS. We've not been given the length of SQ, so we need to find it. To get SQ, we apply the sine rule to triangle PQS. This gives us SQ divided by sine 56 degrees equals 32 centimeters divided by sine 62 degrees. When we make SQ the subject, this is what we have, which is equal to 30.046 centimeters. So now we make SR the subject and plug in the values of SQ, QR, and angle SQR into the initial equation. When we type this into the calculator, we get 41.2 centimeters rounded to 3 significant figures. Calculate the shortest distance from P to SQ. The shortest distance from P to SQ is simply the perpendicular line from P to SQ. We've labeled this line as Y. To get Y, we can apply SOHCAHTOA. This gives us sine 62 degrees equals Y divided by 32 centimeters. When we make Y the subject, this is what we have. When we type this into the calculator, we get 28.3 centimeters rounded to 3 significant figures. The table shows information about the mass, m grams of each of 120 letters. Calculate an estimate of the mean mass. The mean is equal to sigma f of x, which represents the total mass of all the letters, divided by sigma f, which is the total number of letters. Before getting sigma f of x, we need to find the midpoint mass for each of the mass intervals. So for the first interval, the midpoint mass is 0 plus 50 divided by 2, which is 25. Then we have 50 plus 100 divided by 2, which is 75. 100 plus 200 divided by 2, which is 150. 200 plus 500 divided by 2, which is 350. So for sigma f of x, we have 25 times 43 plus 75 times 31 plus 150 times 25 plus 350 times 21 grams divided by the number of letters, which is 120. When we type this into the calculator, we get 121 grams rounded to 3 significant figures. Iraj draws a histogram to show this information. He makes the height of the first bar 17.2 centimeters. Calculate the height of each of the remaining bars. The height of a bar on a histogram is determined by its frequency density. Here is the formula for finding the frequency density. For the first interval, the frequency density is equal to the frequency, which is 43, divided by the interval width, which is 50 minus 0. This gives us 0.86. Since the height of the interval drawn on the histogram is 17.2 centimeters, then it means 0.86 times a certain scale factor should be equal to 17.2 centimeters. This scale factor is 20. So for the interval m is greater than 50 and less than and equal to 100, its height will be 20 times the frequency density, which is 31 divided by 100 minus 50. This gives us 12.4 centimeters. For the interval m is greater than 100 and less than and equal to 200, its height will be 20 times the frequency density, which is 25 divided by 200 minus 100. This gives us 5 centimeters. Then for the interval m is greater than 200 and less than and equal to 500, its height will be 20 times the frequency density, which is 21 divided by 500 minus 200. This gives us 1.4 centimeters. Complete the cumulative frequency table. For m is less than and equal to 50, the cumulative frequency is 43. For m is less than and equal to 100, the cumulative frequency is 43 plus 31, which is equal to 74. For m is less than and equal to 200, the cumulative frequency is 74 plus 25, which is equal to 99. Then finally, for m is less than and equal to 500, the cumulative frequency is 99 plus 21, which is equal to 120. Draw a cumulative frequency diagram. On the grid, we plot the points from the table in part C. When we are done, we connect the points with a smooth line. Use the cumulative frequency diagram to find an estimate for the median. To get the median, we map half of 120, which is 60, on the diagram. This gives us the median as 75 grams. Find an estimate for the upper quartile. To get the upper quartile, we map 3/4 of 120, which is 90, on the diagram. This gives us the upper quartile to be 160 grams. Find an estimate for the 40th percentile. To get the 40th percentile, we map 40% of 120, which is 48, on the diagram. This gives us 55 grams. Find an estimate for the number of letters with a mass m, where m is greater than 250 and less than and equal to 400. First, we map 250 grams on the diagram. This gives us 106. Then we map 400 grams, which gives us 118. So the number of letters in the range is 118 minus 106, which is equal to 12. The interior angle of a regular polygon is 156 degrees. Calculate the number of sides of this polygon. Here is the formula for the size of an interior angle in a regular polygon. We've been given the interior angle to be 156 degrees, and we want to find n, which is the number of sides of the polygon. When we multiply both sides by n, this is what we have. 180 times n is 180n, and 180 times -2 is -360. When we group like terms, we have 24n equals 360. When we divide both sides by 24, we have n equals 15. A, B, and C lie on a circle center O. Angle OBA is 52 degrees. Calculate angle ACB. First, we see that OA and OB are radii of the circle, which makes triangle AOB an isosceles triangle. Base angles in an isosceles triangle are equal. The sum of the angles in triangle AOB should add up to 180 degrees. So to get this angle, we subtract 2 times 52 degrees from 180 degrees, which gives us 76 degrees. The angle chord AB subtends at the center of the circle is twice the angle it subtends at the circumference of the circle. This means angle ACB is half of 76 degrees, which gives us 38 degrees. P, Q, R, S, and T lie on a circle. WSR is a straight line and angle WSP is 112 degrees. Calculate angle PTR. Angles on a straight line add up to 180 degrees. So when we subtract 112 degrees from 180 degrees, we get 68 degrees. Chord PR subtends two angles at the circumference of the circle. These angles should be equal, and so angle PTR should be 68 degrees. G, K, and M lie on a circle center O. FGH is a tangent to the circle at G, and MG is parallel to OH. Show that triangle GKM is mathematically similar to triangle OHG. Give a geometrical reason for each statement you make. An angle formed between a radius and a tangent is 90 degrees, so angle OGH is 90 degrees. Angle GMK is also 90 degrees because an angle formed in a semicircle is 90 degrees. These two are alternate angles, and we know that alternate angles are equal. The three angles in both triangles must add up to 180 degrees. So if two of those angles are equal, then the third angle in both triangles must also be equal. We've shown that all the angles in both triangles are equal. So based on the AAA criteria, they are mathematically similar. Two rectangular picture frames are mathematically similar. The areas of the frames are 350 centimeters squared and 1134 centimeters squared. The width of the smaller frame is 17.5 centimeters. Calculate the width of the larger frame. For similar shapes, the ratio of their areas must be equal to the square of the ratio of their corresponding sides, which in this case is their widths. When we make the width of the larger frame the subject, this is what we have. WS is 17.5 centimeters, AL is 1134 centimeters squared, and AS is 350 centimeters squared. When we type this into the calculator, we get 31.5 centimeters. A picture in the smaller frame has length 15 centimeters and width 10.5 centimeters, both correct to the nearest 5 millimeters. Calculate the upper bound for the area of this picture. To correct the length and width to the nearest 5 millimeters, we bring their dimensions, then plus and minus 5 millimeters, which is the same as 0.5 centimeters divided by 2. We are interested in finding the upper bound of the area, and that will be equal to the upper bound of the length times the upper bound of the width. The upper bound of the length will be 15 plus 0.5 over 2 centimeters, and the upper bound of the width will be 10.5 plus 0.5 over 2 centimeters. When we type this into the calculator, we get 163.9375 centimeters squared. In a sale, the price of a large frame is reduced by 18%. Pathy pays $166.05 for 5 large frames in the sale. Calculate the original price of one large frame. If the sale price for 5 large frames is $166.05, then the sale price for one large frame will be $166.05 divided by 5, which is equal to $33.21. Since the sale price is an 18% reduction on the original price, we subtract 18% from 100%, which gives us 82%. So we have 82% of the original price equals $33.21. When we make the original price the subject, this is what we have, which is equal to $40.50. Pathy advertises a large frame for a price of $57 or 48.20 euros. The exchange rate is $1 equals 0.88 euros. Calculate the difference between these prices in dollars and cents, correct to the nearest cent. We need to convert 48.20 euros to dollars, so we set up the conversion ratio. When we cross multiply and make x the subject, this is what we have, which is equal to $54.77 rounded to the nearest cent. Therefore, the difference between the prices would be $57 minus $54.77, which is equal to $2.23. Dapan runs a distance of 12 kilometers and then cycles a distance of 26 kilometers. His running speed is x kilometers per hour and his cycling speed is 10 kilometers per hour faster than his running speed. He takes a total time of 2 hours 48 minutes. An expression for the time in hours Dapan takes to run the 12 kilometers is 12 over x. Write an equation in terms of x for the total time he takes in hours. The total time he takes would be equal to the time he takes for the first part of the journey where he runs plus the time he takes for the second part of the journey where he cycles. We've been given the total time as 2 hours 48 minutes. To convert 48 minutes to hours, we divide 48 by 60. To get the time duration for each part of the journey, we divide the distance by the time. We've already been given the time for the first part as 12 over x. To get the time for the second part of the journey, we simply divide the distance, which is 26 kilometers, by the speed, which is x plus 10 kilometers per hour. 248 over 60 simplifies to 14 over 5. Show that this equation simplifies to 7x squared minus 25x minus 300 equals 0. When we multiply through the equation by 5x times x plus 10, this is what we have. When we expand the brackets, 60 times x is 60x. 60 times 10 is 600. 14x times x is 14x squared. And 14x times 10 is 140x. When we move all the terms to one side of the equation and group like terms, this is what we have. The terms have a common factor of 2. So when we divide through the equation by 2, we are left with 7x squared minus 25x minus 300 equals 0. Use the quadratic formula to solve 7x squared minus 25x minus 300 equals 0. You must show all your working. Here is the quadratic formula. In this case, A is 7, B is negative 25, and C is negative 300. When we plug in these values into the formula, this is what we have. The numbers under the square roots, negative 25 squared minus 4 times 7 times negative 300 gives us 9,025, and the denominator 2 times 7 gives us 14. For the first possible value of x, we have 8 4 over 7, and for the second possible value of x, we have negative 5. Calculate the number of minutes that pan takes to run the 12 kilometers. From part A, we've already found that the time he takes to run the 12 kilometers is 12 over x hours. In part C, we found two possible values of x. Time cannot be negative, so we use the positive value of x, which is 8/4/7. To convert this to minutes, we multiply by 60. When we type this into the calculator, we get 84 minutes. The volume of a paper cone of radius 2.4 centimeters is 95.4 centimeters cubed. The paper is cut along the slant height from O to AB. The cone is opened to form a sector OAB of a circle with center O. Calculate the sector angle x degrees. We can find the sector angle by applying the arc length formula, which is arc length equals theta over 360 degrees times 2 pi r, where the arc length in this case is AB, theta is x, and the radius r is OA. When we make x the subject, this is what we have. So now we need to find OA and AB. Let's start by finding the arc length AB. When the cone is cut, the circular base of the cone becomes the arc length AB of the sector. To get the circumference of the base of the cone, which is the same as AB, we apply the formula C equals 2 pi r, where r is 2.4 centimeters. This gives us 4.8 pi centimeters. Now let's find OA. Remember that the cone was cut along its slant height to form the sector. So the slant height L of the cone is the same as the radius of the sector, which is OA. To get the slant height, we first need to find the height of the cone. We've been given the volume and the radius of the cone, so we can find its height using this formula. When we make h the subject, this is what we have. When we plug in the values of v and r into the equation, this is what we get. When we type this into the calculator, we get 795 over 16 pi centimeters. Now that we know the height of the cone, we can find the slant height by applying the Pythagoras theorem. This gives us L squared equals h squared plus r squared. When we make L the subject and plug in the values of r and h, this is what we have. When we type this into the calculator, we get 15.997 centimeters. Therefore, OA is also 15.997 centimeters. So now we plug in the values of OA and AB into the equation we have for x. When we type this into the calculator, we get 54.0 degrees rounded to 1 decimal place. An empty tank is filled using a cylindrical pipe with diameter 8 centimeters. Fuel flows along this pipe at a rate of 2 meters per second. It takes 24 minutes to fill the tank. Calculate the capacity of the tank. Give your answer in liters. Here is the formula for the volume flow rate. In this case, we are interested in finding the capacity or the volume, so that will be equal to the volume flow rate times t. We've already been given the time t as 24 minutes. So what we need to find is the volume flow rate. So to get the volume flow rate of the fuel into the tank, we multiply the cross-sectional area of the cylindrical pipe by the linear flow rate of the fuel through the pipe. The cross-sectional area of the cylindrical pipe is in the shape of a circle, and the area of a circle is pi r squared, where r in this case is 8 centimeters divided by 2. We convert 8 centimeters to meters by multiplying 8 by 10 raised to the power negative 2. We've been given the linear flow rate to be 2 meters per second. When we type this into the calculator, we get 2 pi over 625 meters cubed per second. Now that we have the volume flow rate, we can find the volume of the tank. We are told that it takes 24 minutes to fill the tank. So the volume of the tank is equal to 2 pi over 625 meters cubed per second times 24 minutes. We convert 24 minutes to seconds by multiplying 24 by 60. When we type this into the calculator, we get 576 pi over 125 meters cubed. 1 meter cubed is 1000 liters. So to convert this value to liters, we multiply by 1000. This gives us 14,500 liters rounded to 3 significant figures. Expand and simplify. X plus 1 times x minus 2 times x plus 3. When we expand x plus 1 times x minus 2, we get x squared minus x minus 2. To expand these two brackets, we pick each of the terms in one bracket and multiply it with all the terms in the other bracket. When we do that, this is what we get. Minus x squared plus 3x squared is 2x squared. Minus 2x minus 3x is minus 5x. And so our final answer is x cubed plus 2x squared minus 5x minus 6. Make G the subject of the formula. M equals 2fg over g minus c. When we multiply both sides by g minus c, this is what we have. When we expand the brackets, m times g is mg and m times negative c is negative mc. We want to make g the subject, so we move all the g terms to one side of the equation. When we factor out g, we are left with m minus 2f. When we divide both sides by m minus 2f, we have g equals mc over m minus 2f. Simplify. 4x squared minus 16x over x squared minus 16. For the numerator, when we factor out 4x, we are left with x minus 4. We can rewrite the denominator as a difference of two squares. So we have x squared minus 4 squared. By applying the factorization for the difference of two squares, we can rewrite x squared minus 4 squared as x plus 4 times x minus 4. X minus 4 cancels out, and so we are left with 4x over x plus 4. The probability that Shalini is late for school on any day is 1 over 6. Complete the tree diagram for Monday and Tuesday. We've been given the probability that Shalini is late on any day as 1 over 6. So to get the probability that Shalini is not late, we simply subtract 1 over 6 from 1, which is 5 over 6. Calculate the probability that Shalini is late on Monday but is not late on Tuesday. This probability is equal to the probability that Shalini is late on Monday and the probability that Shalini is not late on Tuesday. The probability that Shalini is late on Monday is 1 over 6. The probability that Shalini is not late on Tuesday is 5 over 6. The end becomes times. When we type this into the calculator, we get 5 over 36. The Venn diagram shows the number of students in a group of 50 students who wear glasses, who wear trainers, and who have a mobile phone. Use set notation to describe the region that contains only one student. We see that the region that contains only one student is outside all the three sets. So we can represent that as G union T union M complement. Find N of T complement intersection G union M. In other words, we are to find the number of students who wear glasses or who have a mobile phone but do not wear trainers. After shading this region on the Venn diagram, we see that the number of people in the region are 0 plus 19 plus 9, which is equal to 28. One student is picked at random from the 50 students. Find the probability that this student wears trainers but does not wear glasses. This probability is equal to the number of students who wear trainers but do not wear glasses divided by the total number of students. From the Venn diagram, we see that the number of students who wear trainers but do not wear glasses is 3 plus 14, which is 17. So we have 17 over 50. Two students are picked at random from those wearing trainers. Find the probability that both students have mobile phones. The probability that the first student picked from the trainers group has a mobile phone is equal to the number of students who wear trainers and have a mobile phone, which is 16, divided by the number of students who wear trainers, which is 21. Remember, we are picking the first student and a second student. The and becomes times. After the first student is picked, the pool reduces by 1, and so the probability that the second student from the trainer group has a mobile phone is 15 over 20. When we type this into the calculator, we get 4 over 7. Solve the equation tan x equals 11.43 for x is greater than and equal to 0 degrees and less than and equal to 360 degrees. First, we need to find the value of alpha, the reference angle that will allow us to find all the possible values for x in the given range. We find alpha by taking the tan inverse of the positive value of 11.43, which is the same as 11.43. When we type this into the calculator, we get the value of alpha as 85.0 degrees rounded to 1 decimal place. Now we need to draw the quadrants. Since the value of tan x is positive, we are only going to use the quadrants where tan is positive, which is quadrant A and quadrant T. The angle alpha is measured from the horizontal axis in these quadrants. When we go around the quadrants the first time, we get our first value of x as alpha, which is equal to 85.0 degrees. When we go around the quadrants the second time, we get the second value of x as 180 degrees plus 85.0 degrees, which is equal to 265.0 degrees. Sketch the curve y equals x cubed minus 4x. First, let's find the y-intercept of the curve, which is the point on the y-axis through which the curve passes. At this point, the x-coordinate is 0. When we plug in x equals 0 into the equation, we get y equals 0. So we plot 0, 0 on the grid. Now let's find the x-intercepts of the curve, which are the points on the x-axis through which the curve passes. At these points, the y-coordinate is 0. When we plug in y equals 0 into the equation, we have x cubed minus 4x equals 0. We can solve this equation by factorization. When we factor out x, we are left with x squared minus 4. X squared minus 4 can be written as a difference of 2 squares, so we have x squared minus 2 squared. When we apply the factorization for the difference of 2 squares, we rewrite x squared minus 2 squared as x plus 2 times x minus 2. So we have x equals 0, x equals negative 2, and x equals 2. We've already plotted 0, 0 on the grid, so we plot negative 2, 0 and 2, 0. From here, we can find the stationary points of the curve by equating dy dx to 0. When we do this, we see that the coordinates of the stationary points are roughly 1.2, negative 3.1, and negative 1.2, 3.1. After plotting these points, we draw a smooth line passing through all the points. A curve has equation y equals x cubed plus ax plus b. The stationary points of the curve have coordinates 2k and negative 2, 10 minus k. Work out the value of a, the value of b, and the value of k. We know that at any stationary point, dy dx equals 0. When we differentiate the equation of the curve, we get 3x squared plus a. So to get the stationary point, we equate 3x squared plus a to 0. We already know that the x-coordinates of the stationary points are 2 and negative 2. So we can either plug in 2 or negative 2 into this equation to get the value of a. In this case, when we plug in x equals 2 into the equation, we have 3 times 2 squared plus a equals 0. 3 times 2 squared is 12, so a is negative 12. Now that we have the value of a, we can use it to help us find the other values. We've been given the first set of coordinates on the curve as 2k. So when we plug this into the equation, we have k equals 2 cubed minus 12 times 2 plus b. 2 cubed minus 12 times 2 is negative 16. So we have k equals b minus 16, which we have labeled as equation 1. When we plug in the second set of coordinates into the equation, this is what we have. Negative 2 cubed minus 12 times negative 2 is 16. When we rearrange the equation to make k the subject, we get k equals negative b minus 6, which we have labeled as equation 2. So now we can solve the two equations simultaneously to get the values of b and k. Let's use the elimination method. Since we have b in equation 1 and negative b in equation 2, we can eliminate b by adding equation 1 to equation 2. This gives us 2k equals negative 22. When we divide both sides by 2, we have k equals negative 11. To get the value of b, we can plug in the value of k into any of the equations. If we pick equation 1, we have negative 11 equals b minus 16. When we add 16 to both sides, we get b equals 5. Thank you for watching. I hope you found this video useful. See you in the next video. Bye guys.